Hello everyone, I hope that you're all doing well. My name is Richard and welcome to Group Advanced Concepts Presentation number 7. So let's start with a description. So lovastatin, also known as Mevacor, is a drug made by Merck Pharmaceuticals. It is used to lower cholesterol. So our goals for this week were to research the drug lovastatin itself and walk the audience through the cholesterol biosynthesis and how lovastatin inhibits high cholesterol. And also as an aside, if lovastatin goes through any structural changes before becoming active, please discuss this. So this is an overview of lovastatin. So this is what it looks like in its chemical form or molecular form. And this is what it looks like when you buy it on the shelf in its medication form. So it has a couple of brand names, Altacor, Altaprev, and Mevacor, as I previously stated. So lovastatin is in a class of medications called HMG-CoA reductase inhibitors, or statins. This will become important later. So it works by slowing the production of cholesterol in the body to decrease the amount of cholesterol that may build up on the walls of the arteries and block blood flow to the heart, brain, and other parts of the body. So this is the cholesterol pathway that I was alluding to earlier. So as you can see here, there are multiple steps in the production of cholesterol. You start with the HMG-CoA formation, then you have the committed step, phosphorylation, condensation reactions, and finally cholesterol formation. Just to go into a little bit more detail, you have acetyl-CoA and acetoacetyl-CoA. You form the HMG-CoA, then you use the HMG-CoA reductase that we mentioned earlier to form the mevalonate. Then that forms the isopentenyl pyrophosphate, or IPP. That then forms the farnesyl pyrophosphate, FPP. Then that forms the large squalene molecule. And then it eventually forms cholesterol. And then it goes to 3 routes, just as an aside: bile acids or salts, steroid hormones, and vitamin D. So where does lovastatin play in the pathway? Right up at the very start here, during the committed step. So you can see here the HMG-CoA reductase inhibitor. So as it states here in the image, it's an important cholesterol lowering medication. So what it does is it inhibits this. And as you can see from the pathway, this enzyme is responsible for catalyzing the conversion of HMG-CoA to mevalonate. And mevalonate, as you can see, is a required building block for cholesterol biosynthesis. So lovastatin interferes with this production by acting as a reversible competitive inhibitor for HMG-CoA, which bind to the HMG-CoA reductase. So how does lovastatin work? So it is metabolized into its active form, beta-hydroxy acid, in the stomach. So following an oral dosage, a water molecule does a nucleophilic attack on the carbonyl carbon of the drug and opens the ring, resulting in the beta-hydroxy acid form. So you can see over here that this is the inactive form of lovastatin, and you can see that the ring, that once the nucleophilic attack occurs on the carbonyl carbon, as you can see here, the ring opens, and that is what forms the beta-hydroxy acid. This is now in its active form, and it can work to inhibit the formation of mevalonate. So you can see in this image down here that the lovastatin binds to the large domain of the HMG-CoA reductase in a similar way as the binding of HMG-CoA to HMG-CoA reductase. So it is suggested that the bound NADH on HMG-CoA reductase reacts on the terminal carboxylic acid group on the beta-hydroxy acid, similar to its interaction with the thioester group on HMG-CoA. Thus, lovastatin in its beta-hydroxy acid form is the competitive inhibitor of the enzyme HMG-CoA reductase. So in conclusion, we learned that lovastatin is a statin drug used for lowering cholesterol in those with hypocholesterolemia to reduce the risk of cardiovascular disease. It is administered as medication, but it is also found naturally in foods such as oyster mushrooms, red yeast rice, and pu'er tea. So once it's ingested, the lactone group in lovastatin is hydrolyzed and will open up, forming the terminal carboxylic acid group on the beta hydroxy acid, its active form. Again, as you can see here, closed, open. And by inhibiting the HMG-CoA reductase enzyme, mevalonate cannot be formed and cholesterol production cannot continue. This is how it lowers cholesterol levels in the body. Thank you very much.